Yeah. Good. Looks like we are covering from early morning till late in the evening. So thank you all for joining from the various places today to ceramic MBR, how to upgrade from polymeric membranes and why it matters. We're very excited you're here today. What we are hoping you will learn is a bit more about where is ceramic in the filtration market, what are the benefits using ceramic membranes, specifically in MBRs, how to upgrade from existing systems to MBRs, to ceramic MBRs, and we walk you through some of the case studies and some of the lessons learned. We'll be presenting for roughly 30 minutes, and we have some Q&A at the end. So please use the Q&A button, maybe at the top or at the bottom on the Zoom bar, and type in any question you have during the webinar. We'll receive them in the back end, and we will answer all of the questions at the end. Some of it, which we believe is good for the entire group to know, we will cover live at the end, and all others we will answer separately. But rest assured, every question will be answered. Another short housekeeping, and then we get started. If you want to contact us for any opportunities or any questions for MBRs or for other applications, whether it's drinking water, seawater pretreatment, produced water, river water, you name it, email webinar@cerafiltec.com, and we will connect you with an engineer or consultant, and we can further the discussion. And lastly, I want to welcome Edna to the presentation. We had a last-minute change in speakers. Edna is our global MBR technology expert, and she will cover especially the later part of the presentation about all of the case studies.
Hi, everyone, and welcome to this webinar.
Thanks, Edna, for jumping in.
Anytime.
Okay, so without further ado, let's jump right in. And I'll start by saying, thank you, MBR Solutions. MBRs are very successful, and as you can see here in the graph, fast-growing technology. It is a mature technology. It is fully established with well over 5,000 installations globally. I think the benefits are clear to everyone. Super compact, small space compared to conventionals, removal of all bacteria and suspended solids. So it's the ideal wastewater treatment plant for reuse. However, and there's a but in there, it has some inherent limitations. And these limitations typically manifest on the membranes. Doesn't matter where the problem lies, the Achilles heel is always the membranes. And we see fiber breakages, a lot of maintenance work, plants upset, cleaning requirements. So these are, despite MBR being a great technology, the shortfalls. So if we look at the universe of root causes, where these problems start, it starts as early as in the MBR design. Too aggressive flux design or unpredicted feed water quality. We see in the biological design, stress bacteria or over and under designed biological system. Chemical cleaning can lead to material decay of the polymeric membranes and ultimately to fiber breakages and tears that then later have a result on the permeate quality. Insufficient filtrate quality, not meeting the required reuse specifications, or even worse, you have now O at the end that then suffers from the insufficient water quality. So how do we unlock the potential of filtration? How do we unlock the full potential of MBRs? And wouldn't it be great if there was a solution that could operate independent of the feed water quality, that was resistant to chemicals, and that could always be recovered even if there was an upset in the plant? And that's exactly where ceramic membranes come to play. Ceramic membranes unlock the potential of MBRs, a robust and reliable solution that has no fiber breakages, that can operate even during peak events like oil, for example, that has 3 to 4 times the service life of polymeric membranes, expected 20 years. that is chemical resistant, that if harsh cleaning is needed because of an accident or peak event, it's possible without worrying about ppm hours or with worrying about warranties. That can be fully recovered if you have a plant upset upstream or failing equipment and the membranes suffer, that they can be recovered. And ultimately, all of this boils down to operational benefits, to operational cost benefits, and to membrane lifetime savings. So a lot of people believe that ceramic membranes are only used in niche applications. And while this was true 10 years ago, it's not true anymore today. Today, ceramic membranes has the same market share of the global ultrafiltration and microfiltration industry as Bose has in the headphone space. Bose is a main player for headphones, just as ceramic is a dominant player in the filtration world. And we wanted to illustrate this to show that ceramic is not in niche applications. It's on path to become fully mainstream. To illustrate this further, I think this graph says a lot. When Cerafiltec was founded in 2016, ceramic membrane market share of the global MFUF membrane market across all applications was about 1 to 2%. Today, ceramic membranes make up about 10% of the global MFUF membrane market. So needless to say that ceramic membranes are starting to displace polymeric membranes. And it's easy to predict where the future will go and how much market share more ceramic membranes will be able to capture. Especially knowing that ceramic membranes continue to become more competitive, continue to increase performance. We're still at the infant stages of what we will see, what the technology can bring to bear. And this is nothing new. If you look across industries, every technology goes through transitions. So if we take a simple example of a light bulb and we look at the journey that a standard light bulb had, and that's being displaced now by LED light bulbs. If you think back when you were little, you know, the light bulbs that you had to unscrew every 9 months to replace it, today is fully replaced by LED light bulbs. Initially, early 2000s, LED light bulbs were way expensive. They were only used in niche applications like microelectronics, and nobody really knew about it. Until the competitiveness of LED light bulbs improved, long lifetimes resulted in a lower total cost of ownership. Using LED light bulbs, the consumer market became aware of it. Sustainability drivers helped LED light bulbs accelerate. And all of a sudden, fast forward 2025, LED light bulbs completely displaced standard light bulbs with now 95% global market share in the light bulb industry. Ceramic membranes are following the same trajectory. And this is, again, across all technology sectors. Authoritative organizations like Global Water Intelligence also recognizes this trend. Ceramic membranes are becoming mainstream. Seeing multiple 100 MLD plant capacities using ceramic membranes is not a rare instance anymore. We see installations in multiple countries from multiple providers across multiple applications being embraced more and more by consultants, engineering companies, system integrators, and end users. So ceramics are becoming mainstream. Enough about the market. I hope the trend is clear and why it's important to look at ceramic membranes if you're in the water treatment space. Let's talk about the product. Ceramic membranes come in different shapes and forms. Cerafiltec has what you see on the right side, what we call a module. That module has 6 square meters filtration area. Since we're in an MBR webinar, everything is about submerged solutions. So we operate in an open tank, out to in filtration. So the water surrounding the membranes comes into the hollow channels of the membranes and then with suction pressure gets transferred out. The pore size is 0.1 micron. The module has all internal filtered water piping, so there's no external piping that needs to be installed or adjusted. There are also no metal parts, meaning in high TDS application, there is no corrosion. The module is about the size of a small suitcase and weighs as much as 2 crates of water. So 2 people can easily handle such solution. To look at this in a more broader concept, all of these modules can be stacked up to a tower, and multiple towers make up an entire system. The beautiful thing is that it's very modular. That means we can fit ourselves into any existing trains, in existing tanks, whether it's an upgrade from a polymeric membrane plant or whether it's a gravity sand filter plant or any other tank. We can fit and mold ourselves into that space and use existing infrastructure. If we compare all of the available membrane solutions across different metrics, hollow fiber membranes, polymeric membranes, ceramic membranes, and benchmark them in this overview, that's what we arrive at, fully recognizing that these are average values. But we wanted to give at least a proxy how things compare to one another. We recognize that flux rates can range widely and lifetimes can range widely. But the main takeaway really from this table is that as commonly known, ceramic membranes in the MBR application specifically are a little bit higher on the CapEx side, but they are lower on the total cost of ownership side, on the membrane lifetime cost. On top of this, there's lower maintenance costs connected to design, connected to replacements, connected to operations. And if the MBR struggles with the feed water quality, with the membranes installed, and the membrane lifetime actually ends up on the lower side, which we've also seen commonly on the 3 to 5 year side, substantial economic benefits can be achieved utilizing ceramic membranes. But most importantly are these 3 line items at the bottom: chemical lifetime exposure, oil tolerance, and recover sludging events. This is ultimately the ceramic membrane insurance policy. MBR plants are built in anticipation to operate for decades, or at least, let's say, 10, 20 years. And it is almost certain that something will happen not according to plan during this time. And that's when the insurance policy, in quotation marks, is really helpful. Whether you have an oil spill or oil reaching the membranes, or equipment fails that then causes a sludging event, or harsh chemical cleaning is needed, a ceramic membrane really provides this reliability, the security, the peace of mind for the operator. And this is where we would like to share a couple of stories. So the theme is expect the unexpected. That's the reality of operating a wastewater treatment plant. And Edna, if you don't mind quickly talking through this, you've been at site at this specific instance, and I think you can best tell that story.
Sure. Thanks, Julius. So anyone who has ever had anything to do with biological wastewater treatment or an MBR site knows that things go wrong, and that once things go wrong, they usually go wrong drastically with severe consequences. And typically the membrane, as the last part in the operation chain, is the one that bears the brunt of the damage. So with the ceramic membranes, we have the exact same thing. Something goes wrong, some are completely membrane unrelated, but the damage gets done to the membranes. So on the first picture, what you see is this is how it looks like when we take a module out after a year or 2 of operation. This is the normal biological fouling we see on the membrane surface. This is fully recoverable by a chemical backwash. This is what we consider a normal module after operation. The second picture, on this specific side, we had an upset with the aeration system. The blowers were turned off for several days without the operators really noticing it. The reason why they didn't notice it was the plant was actually still performing at design capacity. They did not see a shortfall of filtration, the permeate quality was good. The transmembrane pressure was rising a bit, but still within the limitations. So at first they ignored it until the pressure kept rising and they couldn't recover the membranes anymore. And then they had a look, and that's what they found. The entire tower at this plant, we had 13 modules high towers, was filled up with sludge. It was one solid column of sludge. And not just wet sludge, the sludge had dried in between the plates. It was a complete mess. So what we did there on site, we took out all the towers, all the modules, separated them, cleaned them with pressure washers. So thanks to the hardness and robustness of the ceramic, we could really go in there with high pressure water jets and clean up all the dried sludge that had accumulated in the modules, completely clean it up, and then put the towers back together in the end, reinstall the membranes, and the plant is performing as of day one. We had absolutely no impact on the flux rates. We had no impact on the transmembrane pressure. The membranes perform as new after this. And this is an example of an insurance policy, because these sludge events, these things happen. Blowers do fail. Sometimes the operating staff doesn't catch it in time, and you have a huge amount of sludge in between your membranes. But the ability to clean it, that's unique to ceramic. If you have that amount of sludge in a hollow fiber or in a flat sheet module, there's no way you can recover that again. With ceramics, you can.
Thanks, Edna. Another expect the unexpected scenario here, also real life situation. Oil resistance is the benefit. Typically, MBRs are designed in a way that the membrane should not see any oil. But what if they do? You cannot control what goes into the sewer. Whether it's a municipal treatment plant or an industrial treatment plant, oil is part of the risk profile. And this is where ceramic membranes have a unique advantage. Not only are they oil resistant, meaning they don't break when they're exposed to oil, but we can even operate in oily feed water. This particular plant operates with about 1,000 ppm. We had a very similar instance where a brand new polymeric membrane was installed in an MBR. High levels of oil came through. The membranes were 1 week old, and that was the end of it. Replaced with ceramic membranes 4 years ago, operating since then flawlessly, despite high levels of oil still in the feed water very frequently. So with oil, also here, same theme. Ceramic is your insurance policy. Expect the unexpected. Another quick story here on chemical resistance. Expect the unexpected. I think it's common knowledge that with every chemical cleaning, by the nature of plastic, of polymeric membranes, the material decays, becomes brittle, and ultimately leads to breakages. And we had an instance with a large installation where the operator, by accident, cleaned the entire train instead of with 200 ppm NaOCl, with 20,000 ppm NaOCl. Any polymeric membrane would be for certain out of warranty, but also most likely be completely damaged. The ceramic membrane said, thank you, we are as brand new membranes now, we are completely clean. So also here, your insurance policies, things happen that are not planned. And then with everything coming together, if you can react on these unexpected events and you can fully recover the membranes, and you have this insurance policy for unexpected events, and you don't have to replace them, then you really get the benefits of longevity. This particular plant now here smoothly operates for 14 years. The membranes installed look exactly the same today as they did on day number 1. And in all likelihood, they will operate another 14 plus years. The operator swings by the plant every 6 months, does a very strong chemical cleaning, and that's pretty much it. Since then, since first day, we never had any maintenance or we never had any replacements. I think this speaks volumes. Now, with that being said, let's dive into how to actually upgrade existing MBRs with ceramic membranes. And Edna will take us through this and then also talk about some of these case studies.
All right, so how do we upgrade normal MBRs to ceramic MBRs? First step, I think, is with every project, so this is true for upgrades as well as for new greenfield projects, is data collection. Obviously, we need to know what type of project we're dealing with. We need to know what water we're dealing with, what's the plant capacities, are there peak events, what are the existing tank dimensions, existing infrastructure, and so on. So for this, we have a questionnaire on our website, our request for quotation form. You can find it on the website. You can fill it in. It will be sent to us, and you will be hearing back from us with either more questions or with a preliminary design offer. So once the data collection step is done, we then proceed to step 2, which is the root cause analysis. So this is specific to upgrade of polymeric to ceramic MBRs. So typically what we get are requests to exchange broken polymeric membranes. But the fault isn't always the membranes. The fault could be somewhere else in the system. So very important for us is to do a detailed root cause analysis, go through the entire process from the entry of the wastewater to the system all the way to the end to the membranes and see what is not working. Why are things not working? Is it really the membranes that just couldn't cope with the water quality that's coming? Or is the fault somewhere else in the process? Is it the screens that are not working good enough? Is it the biological treatment that is not producing sludge in the quality that we would need? So we will go with you together through the entire process to make sure that we really find out where the key problems are and solve them together with you. Once we've done all that, then we look into the designing your system with our ceramic membranes. And for that, we will provide you projections detailing exactly the flow rates, the flux rates, equipment requirement for pumps, blowers, and so on. We will provide you with a P&ID, with layout drawings, 3D modeling drawings if required. We have a functional description for MBR processes, so you can adjust your PLC accordingly. And we, of course, will evaluate whatever equipment you have already existing on site so we can integrate it with our operations. Especially for industrial applications or very tricky wastewaters, we can also perform an on-site demonstration. We have a little demo unit that comes with a small membrane module. Doesn't require any installation on site. It can be put directly into either an aeration tank or a membrane tank. It comes with its own pump, with its own air supply, control unit, and can be left on site unsupervised for a day or two to give you an idea of the flux rates, of the transmembrane pressure we can achieve, the cleaning intervals we would require, and so on. So this is a really neat feature that we do in order to make sure that our design actually matches to the site requirements. Once that is done, the design is done, you're clear that you want to exchange to ceramic membranes, and then we look into the actual tanks. What modifications do we need? How can we install our membranes into the given infrastructure that is already there? So typically we will need some kind of support frame at the bottom where we integrate our aeration system, where we lift the towers off the ground to allow for proper sludge circulation. And then we will put in the headers on top. These have to be aligned properly to the existing main headers. Most of the time, this is no problem. Sometimes we need to exchange the entire header system. That depends on how it was built before. The degassing system is something, Julius, go back. Degassing system is typically already on site and available. We just check the capacity. As long as it works for us, we will leave it alone. Aeration system, as I said, is going to be changed over to our own aeration system, which comes with the frames. And backwash systems sometimes have to be added, especially if we work with polymeric flat sheet membranes that are not backwashable. In that case, we would have to retrofit a backwash system into the process. And then the final step, once all the plans are done, we go into installation. So what you can expect from us and from our experts in that step would be, we take care of giving you guidelines on all the equipment integration. We will be there on site with you to supervise the commissioning and installation of our modules. We will provide operator training, and we're also always available for performance review and optimization. So even once it's installed, we've handed over the plant, you can always reach out to us, ask questions, request someone from us to go on site for a review. We will not leave you alone with the system. Here we have some examples how we have replaced existing polymeric membranes. In this case, it was a flat sheet membrane installed in a round tank, which is not the optimal installation, but sometimes you just have to live with what we find on site. And you can see the ceramic membranes actually take a lot less footprint than the polymerics in this case. So we easily fit into the existing tanks, have lots of room around. And when we compare that to hollow fibers, then we see that even for hollow fiber systems, we are able to do a one-on-one replacement. But there the tank fit is a bit tighter, and generally ceramic membranes take a slightly more or equal footprint to the hollow fibers. But so far we've managed to fit into most tanks given the highly modular design of our towers. Okay. Right, then we come to the last part of our webinar, which are the few examples of existing installations. The first one is a food and beverage plant. They were having problems with the existing hollow fiber membranes. They had to exchange them every 2 to 3 years because they had lots of fiber breakages due to very sticky sludge that got accumulated in between, and they had to go in and repair the fibers at least once a month, and the operators on site were fed up with that kind of hassle, and they wanted something that is more reliable and allows them operation in a headache-free environment. We switched the entire plant over to ceramics, and it's now been operating for almost 3 years. And happy to report we haven't had a single problem with the membranes there in terms of breakages. And they are finally able to run the reverse osmosis unit behind it without any problems. Move on to the next one. This is a plant in Italy. They are treating a very difficult wastewater. It comes from ships. So this is a marine wastewater treatment plant. So basically whatever wastewater ships have, they'll deposit at this plant. This can be their municipal wastewater from their kitchens, from their toilets. It can also be all the wastewater they produce by cleaning out tanks or equipment or cleaning the engines. So we have a range of water qualities from normal municipal wastewater all the way to heavily industrial oil contaminated wastewaters. And every day the wastewater looks different. So this is a huge challenge for the entire treatment chain, especially for the biological treatment. So we also see highly fluctuating sludge qualities on the membranes. Despite all that, the ceramic is performing absolutely beautifully in this place. The previous polymeric membranes were done after 2 years due to the very frequent chemical cleanings that we required, especially frequent acid cleanings that completely destroyed the structure of the polymeric membranes. And now that the ceramic is in, the operators are extremely happy to report that the cleanings have absolutely no impact on the membranes anymore, and that they finally can run a sustainable operation. This one is a plant in the US, engine manufacturing plant. They have also a high amount of oil in the wastewater. They had problems with the polymeric membranes. They didn't last even a week before breaking down. So the owner of the plant decided to give ceramic a shot. And it's now been installed several years, and it's still running the same way as it was running on day one, despite the high oil content and the really severe wastewater quality. And then this is our last one. This is a huge plant that we have currently in execution. It's expected to be installed by the end of the year, and commissioning will most likely begin in Q1 next year. So this is a plant in the United States. It's going to be treating municipal wastewater, and the permeate is going to be used for cooling towers for a data center. So the key for this project, why they went for ceramic membranes, is reliability. These cooling towers have to work 24/7. They cannot afford to shut off the cooling water onto this data center. And the operators and the owner of the plants have worked with membranes and MBR systems for decades. They have a huge amount of experience, and they will sourcing actively for a solution that is reliable, that will not give them any threats, any problems with broken fibers, with non-working systems. So they went for ceramic to ensure that it works. So the entire design of the plant is for security. It's with a very conservative flux by design. It's with the redundancies for almost every single item in there to make sure that really there is always 24/7, all year round, a steady supply of water. And that's what we will achieve with this plant once it's in operation next year. Also, little detail to the side, this will then by next year be the largest ceramic MBR in the world once it's in operation. So we're absolutely proud to be involved in this, and we can't wait to see it running.
Thank you, Edna, for going through the technical slides here, specifically the case studies. And I can only echo the most recent project. Super excited to be part of it. And that concludes the presentation, and we're here now in the Q&A session. So before we start with answering some of the questions that came through, just a quick reminder, you can email us at webinar@cerafiltec.com if you have anything you want to discuss with an engineer or a consultant across any applications, or if you wish to see how ceramic membranes work at your plant. As Edna mentioned, we have tools available, pilot units, smaller pilot units that we can deploy for one day for a simple trial to show TMP, to show filtered water quality. Contact us. And we leave the screen open while we answer some of the questions here. So feel free to submit more questions if you have any. I'll just read them out loud, and then we will cover them. So what is question number 1? What is the design flux in LMH for domestic wastewater treatment under both full cell operation and N-1 redundancy? Perhaps Edna, you can address that question.
So for municipal wastewater, we typically design a design flux, annual average design flux of around 35 to 40 LMH, a bit temperature dependent. For full cell operation or N-1 operation, it's the same average flux. The only difference is the peak fluxes that we go with N-1 will be higher than if you have to have the full cell applications, but the average fluxes will remain the same. Second part of the question was regarding the screens. We recommend 1 to 2 millimeter mesh screen or perforated plate screens in order to keep the solids in the membrane tanks at a bay. Otherwise, we'll accumulate too much.
Thanks, Edna. The second question is about how economically efficient is it compared to MBRs. I think the question centers around the economics of ceramic membranes again to, I think, polymeric membranes. And here again, we recognize ceramic membranes is a bit more expensive on the CapEx side, but it has the insurance properties and elements and benefits over polymeric membranes that we covered here in this presentation. And especially when the polymeric membranes have, let's say, a lifetime of 3 to 5 years, which we see especially in industrial MBRs or MBRs that are designed aggressively, then ceramic membranes gives a very substantial advantage on total cost of ownership. So this is really where the benefits are, plus the insurance benefits that we talked about. Next question, Cerafiltec. Oh, this is maybe a more commercial question. We get in touch with Bayu. what is the typical operating transmembrane pressure and what is the maximum allowable TMP in the system? Perhaps Edna, you can address that.
Yeah, so typical operating transmembrane pressure is around 100 millibar. A maximum allowable TMP during filtration would be 600 millibar, and during backwash, 1.2 bar.
And can you also address CIP frequency?
Yeah, so CIP frequency is for ceramic for municipal plants, I would say once to twice a year. But we do have a CEB, which is a chemically enhanced backwash, which typically happens about once a week.
Excellent. And then Mohammed asked, are there any case studies in which Cerafiltec membrane installed in parallel to polymeric membranes? And no, unfortunately not. I think there are plenty of studies that the POB has published on ceramic membranes. If you want to dive into that, the POB also strongly advocates for ceramic membranes in MBR as well as in seawater, building actually an even larger ceramic membrane plant that we are currently building, I think 75 MLD or even higher. So fully embracing the technology. And they published a lot of studies, but unfortunately we don't have a full-scale parallel operating plant with two different technologies. Why did we normalize the cost or the economics to cubic meter per year? Just to normalize it. Ceramic membranes operate at different flux rates, so we needed to normalize it to flux rates and wanted to illustrate really the lifetime savings, so I had to normalize it by time as well. Next question from Ireland. This is also more, what do you mean? Okay, we'll cover that separately. Comparison of alumina to silicon carbide membranes and ceramic pressurized inside out versus flat. Maybe I can comment quickly on the material, and then Edna, you can comment on the pressurized versus flat. So silicon carbide and ceramic are materials both in the ceramic membrane category. Both of them are great technologies. And the benefit with alumina is really twofold. Number one, the pore size is more narrow, so you achieve better filtered water quality. Usually that's very helpful when you have an RO after that. And the second one is that the mechanical strength of alumina is greater, to the order of magnitude of 2x. So in an MBR where you have years and years of, let's say, mechanical stress, a little bit on the membranes through the aeration, we believe that alumina membrane is the solution that is more favorable. So that's why we are really working the MBRs with alumina solutions. And can you talk about the pressurized?
Yeah, when you compare pressurized to submerged systems in MBR, I think the market has given a very clear answer which of the two systems is preferred. It's clearly the submerged. In MBRs, we deal with very dirty water. We deal with high solids concentrations, and you don't really want to have that in an enclosed space where it can get stuck in small spaces, and you need very high pressures to push it through. So yeah, submerged is the way to go for MBRs in terms of filtration.
Then another question here from Hassan. Design flux as noticed 25 to 50 LMH. The question is, do we see this LMH being sustainable at full-scale installations?
Yes, as you've seen in the case studies, we do have operating plants in the range between 25 and I would say 40 LMH as an average flux. 50 LMH would be sustainable for peaks events for a few days, but it's certainly not a flux rate that we would run year round.
Thanks. What is the recommended high pressure to clean ceramic membranes?
I think
So
this
what
refers
backwash
to
pressure?
if it's backwash pressure, then we typically have double the filtration pressure, so it would be 200 to 300 millibar. If it refers to the high pressure cleaning of severely sludged modules, then there we talk about 1 to 2 bar.
Excellent, thank you. What kind of strainer as pre-treatment and coarse or fine screen?
Yes, we obviously have, well, depending on the application, if there's large particles inside, then you definitely need coarse and fine screens. In other cases, especially industrial ones, a fine screen alone would be enough. As I said before, we need 1 to 2 millimeters in mesh or perforated plate screens before our membranes.
Thank you. And then there's a question about, do we use ceramic membranes for fab, semiconductor wastewater? And the answer is yes, we are actually very active in this space. So it would be great to talk about opportunities. We strongly believe that ceramic membranes have, especially the submerged solution, have a tremendous USP in fabs, in semiconductor wastewater. So we'll get in touch there. What is the predominant preferred brand pump used by Cerafiltec?
I don't think we have a preferred pump. This is something we typically leave up to our partners who are doing the installations on site.
What is the operating TMP?
I think we already mentioned that around 100 millibar.
How Cerafiltec membranes perform under fluctuating pH and temperature conditions compared to polymeric membranes?
Generally, they fare better with that, especially fluctuating pH, simply because they have a much higher tolerance in the pH compared to the polymerics. Temperature conditions, the same. They have an impact, of course, on the flux. So the lower the temperature goes, the viscosity of the water changes, and the flux will reduce.
Thank you, Edna. I know
Yeah.
Go ahead. Please go ahead.
No, it's fine.
I know we're at the end of the time, but we have a few more questions. So we will stay on. Anybody who needs to drop, of course, can drop, and we'll stay on and go through the remaining questions. And again, we're here to answer any questions. So we'll do this on this webinar or contact us after, but we'll go through it. The next one, are ceramic membranes compatible with powder activated carbon? Polymeric membranes typically suffer with the abrasive material. Maybe you can address that in MBR specifically. Edna, you're on mute.
Sorry. We have no issue with abrasive substances in the water. We have not tried our ceramic membranes so far with powder activated carbon in terms of MBR. We do that for drinking water applications where we have this active cake layer filtration, but that's a different topic. But in general, powdered activated carbon and ceramic membranes is something that works very well together.
Next question, the MBR project 49 MLD in the US, is it treated wastewater from municipal CAS plant?
Yes and no. It is treated wastewater from a municipal plant, but that plant is so overloaded that the raw water we're getting is basically more or less untreated wastewater. So we're still talking about a COD in the water of around 450 ppm. That's the effluent of a municipal CAS plant.
Good. Then can Cerafiltec remove iron from water level of 17 to 20 milligram per liter naturally occurring groundwater, 17 to 20 milligram liter in the feed? The answer is yes.
Yes.
I can quickly also comment there. We have multiple installations in groundwater where we have similar iron manganese levels going into the membrane filtration. Groundwater is really where ceramic membranes bring their full power to bear. Backwashing every 12 hours, 99% recovery rate. And we operate even in applications where we have multiple 100 milligram per liter of suspended solids and iron manganese from backwash wastewater plants come in. So the answer is yes. Do you have something like biofilters to treat high COD, like 10,000 to 15,000 ppm from textile printing sections?
No, not us. We can treat such waters, obviously, as long as the pre-treatment and the biological treatment in front of it are designed for it. But we don't have specialized equipment to take care of that.
Good. What is the design MLSS concentration in the membrane tank? Can it exceed 12,000 ppm?
So typically we design it around 10,000 ppm. 12,000 is still all right. 15,000 would be our limit. We can go up to 20,000 and higher, but that then has an extreme impact on the flux rates.
The next question, is the Cerafiltec permeate quality suitable to directly go into the RO as feed water?
Yes.
Okay, short answer. Is there any applications of your ceramic membrane following MBR, or is suspended growth always recommended biological treatment before the membrane?
We can do both. We have also both as references. We have a plant that is treating MBBR effluent directly as tertiary filtration. We also have plants that have an MBBR that is followed by a full MBR, so an additional biological step and then membrane filtration.
Then can you share the recording? We wanted to make it special, be part of this webinar, so we don't plan to share the recording, but reach out to us. We can share case studies, any slides you need, any deck you need, any information you need that helps your opportunities in working together. Next question, advanced oxidation with H2O2 and O3 can be performed directly inside the membrane basin, question mark?
Technically possible, yes. The membranes are resistant against these compounds, and we know that aeration with ozone is done with ceramic membranes.
Yeah, actually, there's a plant running, I think, for over 10 years where free ozone passes the membranes, and the membranes operate at extremely high flux rates because there's no fouling and hardly any cleaning done. So ozone and ceramic, or any oxidant and ceramic combinations, are really, really a USP. Could you please, if it is plus 100 millibar, I'm not quite sure what this means. I mean,
that's the TMB. No, it's obviously minus 100 millibar as we are working with suction pressures.
Filtration cycle. What's the filtration cycle? Backwash filtration.
Filtration cycle typically is about 15 minutes of filtration, followed by about a 1 minute relax backwash combined cycle before it goes back into filtration.
Okay, how much is maximum COD, especially for textile water, fluff fiber, incoming feed? Is the issue of fouling by fibers?
It has to be treatable by the biological system in front. That's the limitation, I would say. As long as the biological system manages to get it somewhere around the range of 100, 150 ppm before it hits the membranes, then we're good to go.
And I think the last question here, what is the aeration that we need under the towers? How much air do we need?
Each tower is aerated with 50 cubic meters an hour of air, independent of the tower height.
Which is roughly the same as we need in total for the total plant capacity as polymeric membranes.
Yeah.
Well, there's a couple more questions that come in. Is the air scoring continuous?
Yes, air storing is continuous.
Does Cerafiltec help design complete systems, including biological system, or only take care of the MBR in the tank?
We design only the MBR and the tank. We can assist with the biological system on request, but we don't take responsibility of that design.
Excellent. So this rounds up all of the questions as promised. We wanted to get to every question. If you have other questions, email us. We would really like to stay in touch. Also, follow us on LinkedIn. We plan to have more of these webinars about different applications. We really want to share the benefits of this technology and hope to accelerate this technology transition, as we truly believe ceramic membranes can unlock so much potential in the membrane world. So thank you everyone for joining. Thank you, Edna, and everyone who helped with this webinar. and we'll see you hopefully in the next one. Stay in touch.